Hello, here we are for part B of the 2011 PAT. So we've already gone through the really difficult maths section. So now we're on to the multiple choice physics stuff. Question 12. A boy sitting on a harbour wall observes waves on the water's surface. He sees that the waves have a period of 2 seconds and a single wave travels the length of the harbour wall in 25 seconds. So that's 12 and a half wavelengths that we've got there is equal to 45 meters. So what is the wavelength of the wave? Right, well, we just need to do this then. So the wavelength is going to be it's 25 over 2, so it will be 90 over 25. So 3 25s is 75, so 3.6 meters. C. Right, it's more like it. Question 13. The contents of a refrigerator, which are kept at a temperature T equals 6 degrees, has to be cooled at this rate. That's the temperature of the surroundings. And they've given this constant here, which is the amount of work that needs to be done for each degree Kelvin. The refrigerator has an efficiency of 30%. What is the power consumption on a day when TS is 26%? Right, okay, so we've got that the power is equal to, that's what they just sort of left out of this, alpha times TS minus T. So that is the power, which is equal to, what was it, 15 for alpha multiplied by 26 minus 6. So multiplied by 20. So that's the power, but we've got a problem that is only 30% efficient. So we're going to have to use 10 over 3 more in order to take off that 30%. So the power consumption is going to be, what is all of this? Well, let's cancel that to make it a 3. So we're going to have a 5. I mean, 15 over 3 is 5, not 3. So 5 20s is 100 times 10 is 1,000. So A. Right. So yeah, I mean, it's actually a really easy calculation. They've just worded the question in a confusing manner to try and see if you can actually read. I'm not a big fan of these sort of questions, but once you've picked out, cooled at a rate of means the power there, you can also see it in the units that we got watts per Kelvin, and there's our Kelvin. So this is just working out the power, and then we just need to deal with the 30% efficiency. Question 14. A lunar eclipse can only occur when the moon's phase is which one of these? So for a lunar eclipse, that's where we've got the Earth between the sun and the moon. So it has to be a full moon for the Earth to get in between. The moon has to be on the other side of the Earth for the Earth to get in the way of it and for it to be in shadow. Question 15. 2 stars in the night sky are observed to have the same apparent brightness, but one is known to be at a distance of 10 light years and the other at 20 light years. What's the ratio of the total power radiated by the more distant star? Right, okay, so so brightness is to do with power. We've got a certain amount of energy which is being radiated per second, and then that is passing through this surface area, this sphere, as you get to a certain distance. So that's going to drop off because it's an area as a 1 over r squared. So if we've doubled the distance, then we've got a quarter of the sort of quarter of a dimming effect, 4 times the dimming effect. So if they were the same brightness, it would be a quarter that we would see for the brightness of this because it's twice as far away. So it must be 4 times the power in order to wipe out that effect. So yeah, it's just a 1 over r squared drop off. Question 16. An exoplanet is observed to orbit a nearby star at that distance. At a distance. Okay, all right. So yeah, that's the orbital distance, not the distance of the star. That would make no sense if it was closer than the sun. So yeah, it's orbiting at that distance with a period of 3 days. There's a second one orbiting with a period of 24 days. So what must be its orbital radius. I mean, they're telling us here what a astronomical unit is, I suppose for clarity, but we're not going to need that. This is a Kepler's third law question, the one that people tend to forget, where the orbital period, the square of the orbital period, is proportional to the cube of the distance, the radius of the orbit. So if we've gone 3 days, we've now got 24 days. So we're going to have that 3 squared is proportional to 0.4 cubed. So 24 squared is going to be proportional to some x cubed. So this is 8 squared times 3 squared. Has to be proportional then to 8 squared times 0.4 cubed. That's just multiplying both sides of this top proportionality by 8 squared. So we've got it's going to, I mean, we already know what that is, so we just need to do this bit. We're going to have, what we got here? So that is 8 squared is 4 cubed times 0.4 cubed. So that's going to be 1.6 cubed, which is our answer then, isn't it? Yeah, 1.6 cubed. 4 times 0.4 is 1.6. Yeah, that's right. So yeah, we're just coming out at A. So yeah, that's fine. No great shakes on that one. Right, the usual resistor question. What is the resistance between the points A and B? Okay, so let's work from the inside out on this. So that's going to be a half. That's going to be 1. So we've got 3/2 on that bit, which means we've got a 1 up there and 3/2. So that would be 5/3, 3/5, multiplied by whatever R is. Yep, so D. Yeah, that was fine. The resistor ones are always pretty easy. Transformer is connected to an alternating voltage supplying 240 volts, draws a current of 1 amp. Secondary coil delivers a voltage of 120 volts. So if there's 50 turns in the primary, how many are there in the secondary? Yeah, it's just a straight matchup. V1 over V2 is M1 over N2. So if we've halved the voltage, we've halved the turns. So we must have 25 turns, which is C. An electric motor is driven by a battery of voltage 6 volts, draws a current of 1 amp. Okay, so our power is 6 watts on that. If the motor is used to vertically lift a block of mass 100 grams, what is the vertical velocity of the mass? Right, so we want to have the 6, so that's in 1 second, 6 joules. That's going to be our mgh. So the m times the g is going to be 1. So we're going to be moving at 6 meters per second, which is which is B. Toy car of mass 10 grams rests on a slope of inclination 30 degrees, neglecting friction. What's the acceleration down the slope? Right, so we're doing an F equals ma. So we've got a mg sine 30 degrees. That's our force down the slope. Divide that by the m is going to then give us the acceleration. So it's g times sine 30, which is 5 meters per second squared. A boat crosses a river of width 100 meters flowing in the east-west direction. The water in the river flows from east to west at a speed of 5 meters per second. Okay, so we've got east to west, 5 meters per second. The boat can travel at 10 meters per second. The boat leaves one bank and he wants to reach the opposite bank. Right, okay, so we're going to be doing that at 10 meters per second. What course do we need? Right, well, that's triangle. We got sine half, sine of 30 degrees gives us that half opposite over adjacent. So we need to go 30 degrees east, which is C. Okay, these are, and that's the end of the multiple choice questions. Right, so okay, so as difficult as the maths questions were, these ones have been as easy. So the maths section was really tough. Those multiple choice questions, the 10 of them, were very, very easy, providing you can remember Kepler's third law, there isn't really anything to any of those. So yeah, chalk and cheese so far, this paper.